Okay, so we're going to do area problems. Okay, foiling is going to be involved in these. So let's take a look at the one that has a rectangular fish pond. When you do your setup, you don't need to necessarily do charts, but draw something. That's going to be your setup. So you have a rectangular fish pond. So there's your fish pond. Surrounded by a brick walk that is 2 meters wide, and it's 2 meters wide around all of it. So I'm going to sketch that out. Try to make it look like about the same width all the way around. All right, so from here to here, okay, that is 2 meters wide. Everywhere from here to here, so all along this side, is going to be 2 meters wide. All along this side here, 2 meters wide. And then, of course, all of this from here to here is going to be 2 meters wide. So we're just kind of sketching out what they're describing to us. Now it gives us the area of the walkway. So that's this part right here. This is our walkway. We have the area. So that's kind of like the border, isn't it? So we have the area of the border. Is given to us as 76. Now, do you remember the rectangle problem we did earlier when we had to represent the area of the border? What was that strategy that we used to get just that area of the border? Yes, you are correct. It was the area of the large minus the area of the small. Remember that? You can speak. Okay. So what we need to do is, if we just want the border right here, that means we want to take out the rectangle inside. So we've got to subtract the large area right here, take away the small rectangle here, and we'll be left with that walkway. But we need a length and width for this outer rectangle. Okay, so let's take this length right here. We know that from here to here, they give us the dimensions. The fish pond right here is twice as long as it is wide. So we can represent the length and width on the inside. Who should be the single variable? If the length is twice as long as the width, who would be the single? The width. And the length is twice as long as it is wide, what would that be? Okay, 2W. So we know that from here to here is 2W. Okay, so that would be like from here to here. But the outer rectangle goes beyond that, correct? So we go beyond it how many feet this way? 2 feet that way, and we go beyond it how many feet that way? So overall, how many feet longer is that outer rectangle? 4 feet. 2 feet that way and 2 feet this way. So we know that from here to here is the same as the pond, and that's 2W. But we know we're an additional 4 feet, 2 on each end. Does that make sense? We need to do the same idea then for the width. We know that from here to here is how long? That's your W. But the outer rectangle goes beyond that how many feet? 2 that way, and so again, 4 extra feet. So the pond itself is W, but the 4 extra feet makes that outer rectangle W plus 4. So that's what you've got to figure out, how to represent the length and width of your rectangles. Any questions on that? Okay, so to get the walkway, take the large one, subtract the small one, the pond in the middle. So that's going to be our strategy. The area of the large minus the area of the small, and that equals the area of the border, which we know to be 76. We can put a value there. Okay, how would you represent the area of the large? What expression, how would you set that up? Sam?
2W plus 4 times W plus 4.
This times this. So you have a binomial times a binomial. What do you think we're going to have to do there? Yep, FOIL. Okay, minus the area of the small. This one's going to be a little more basic. The small would be the fish pond. What do we have there? 2W times W. Now remember, this is not distributed property. This is just going to be W times W, which is W squared. So we're going to have 2W squared right here. But this right here, we need to FOIL that out. So go do that. Let's see what we come up with. See if you agree with that. Is that your first line after foiling? What do you notice is going to happen with the 2W squareds? Those will cancel out, because remember, we haven't gone over yet how to solve an equation with a square term. So at this point, we're hoping they cancel out. 2W squared minus itself will be gone. What do those combine to be? Yep, we got 12W plus 16. All right, go through, solve that, see what W is. I hear a 5.
Yes.
He agrees. Are you all coming up with 5? Now you need to go back and look at what they're asking for in the question. Now it says, what are the pond's dimensions? The pond is your smaller rectangle. Dimensions, that means I want the length and I want the width. That's what we mean by dimensions. Give me the length and give me the width. So let's go ahead and do that for the pond. The length of the pond is equal to 2W. And we just found W to be a 5. So 2 times 5. And our unit is in meters. So there is your length, 10 meters. The width of the pond, if you take a look at that, that's just what W was. So what is the width of our pond? 5 meters. Good? Okay, so you'll have quite a few border problems. Let's do the second one. This one is just about a rectangle. We'll sketch out a picture on this one as well. So this one is not going to be a border problem, but you're going to have some that are like this. It's comparing two different rectangles. So it starts with a rectangle that is 10 meters longer than it is wide. So we can go ahead and sketch that out. And how would you represent the length and width? Who would be the single here? 10 meters longer than it is wide. The width. Why don't we make that W? And the length would be, yeah, longer means you're adding on 10. So W plus 10. So there is the rectangle they're talking about in that first sentence. Now then it says, if the length and width are both decreased by 2, so this rectangle is going to get smaller, correct? All right, so let's just kind of sketch out a smaller, slightly smaller rectangle. And figure out how to label it. We need to compare it to the one we just labeled. It says both the length and width. Read carefully because sometimes it might just be one dimension that changes. This is saying both length and width are being decreased by 2. So let's take our length. If we decrease that by 2, how would we represent the new length?
W minus 2.
Careful, what was the whole thing? And then we decreased it by 2.
Or W
Minus?
minus 8.
Plus. Because you have 10 minus 2. So basically you have W plus 10 and then minus 2. So that's going to get you W plus 8. Does that make sense? 2 less than this one would be. So we got to take 2 away from that one as well, and that one would be your W minus 2. So those would be the dimensions of your new smaller rectangle. And it says when this happens, if it is decreased by 2, the area that you have is decreased by 48. So this area is being decreased by 48 to become this rectangle here. So if we take the area of the large one that we started at, decrease it by 48, we get the area of our smaller rectangle, and we can use that to help set up our equation. How would you represent the area of the large? Yep, W times W plus 10. We're going to decrease that by 48. Ah, this one's the good one. Because when you multiply those, what will we have to do? FOIL. Okay, let's go and see what we get for W on this one. We're going to get some W squareds. Hopefully those W squareds will cancel out. Hello? Yes. All right, what do you have on the other side for foiling? W squared.
W squared minus 2W plus 8W minus 10.
Careful.
Or 16.
16, yep. Do you see how the W squareds are going to cancel out here?
Yeah.
Okay. Because they're the exact same on each side, so they're going to be gone. You're left with 10W minus 48. What have we got here?
10W.
Careful.
Negative 10.
A negative 2 plus 8. 6W minus 16. Bring that 6 over, see what you come up with for W. What did you get? I hear an 8. See if you can come up with an 8. Because I think you get 4W equals 32 at some point. What are they asking for, though? Find the original dimensions. Which one was our original? Yeah, the larger one on the left was our original. So our dimensions, okay, the length is the only thing we have to figure out, because that's W plus 10, and now we know that W is an 8. So we get 18 meters for the length. And of course the width is 8 meters, because we're solving right away for W.